Okay, folks, welcome. Today is going to be the last day of the Newton's second law lab, and we're going to kind of do a second experiment today. In our first experiment, we changed the amount of mass on the cart, and yesterday you kind of learned how that affected the net force. Today, we're going to do an experiment where we change the amount of mass on the hanger, and what you're going to do is determine how that affects the net force. And so what we're going to start off with is going over trial 4 of experiment 1. Trial 4 fits in really nicely with the series of data that we're going to collect today. Trial 4 of experiment 1 is going to be kind of like trial 0 of experiment 2. Okay, and so recall from that the mass of the hanger was 50 grams, and in that trial the mass of the car and weights was 758.8 grams. So I think that was because the car was 258.8 grams and the mass that we put on top of the car was 500 grams. So all total, the car with the weight on top of it weighed 758.8 grams. Now remember that we can determine the acceleration from this A value. So the A value was 0.153, and so that means that the acceleration of the car was, if we double that, so 0.1531 meters per second times 2, it's going to be 0.3062 meters per second. Okay, and so then to convert the mass of the hanger to kilograms, we just take that 50 and divide by 1,000. To take the mass of the car plus the mass of the weights and convert it into kilograms, we take that number, divide by 1,000. And then we add the mass of the hanger in kilograms plus the mass of the car and the mass of the weights in kilograms to get the total mass of the system in kilograms. So that's the data that you should have got for trial 4. Okay, and so then what I'm going to do is just review how to calculate the theoretical net force from that data. And then we'll talk about how we could use that data to calculate the experimental net force. Now we kind of already found the experimental net force for all of this data. I'm just going to talk about how you would do it for a single trial, though, not use all the data in a graph to calculate it, just using the data from a single trial to try to estimate what the experimental net force is. So for theoretical net force, remember your equations. So we've got our change in force in the x direction. For this diagram, that's just going to be the tension. That's the only force moving in the x direction. Change in force in the y direction, so that's up and down. Well, we could include the normal force and the force of gravity that's on the car, but those two really cancel each other out, and the car isn't moving up or down. So we're not going to include either of those forces. What we are going to include is the tension on the hanger and then gravity pulling down on the hanger. So our sum of forces in the y direction is our force of gravity minus tension. Okay? And then right, because the whole system is moving together, because the car is connected to the hanger by a string, that means that the car and the hanger are always the same distance apart, which means that they accelerate at the same rate. And so what that tells us is that our sum of forces in the x direction is going to be equal to our sum of forces in the y direction. And that will be mass times acceleration. That's our net force. Okay, and so we're going to get two formulas for our net force. One of them is if we take our sum of forces in the x direction, so tension, we can set that equal to our sum of forces in the y direction, which is the force of gravity minus tension. And then just recall that the force of gravity is just the mass of whatever's being affected by gravity, and then times gravity. Okay, and so to calculate the theoretical net force, we're going to need both of those two equations. And the first thing we're going to do is figure out what the force of gravity is on the hanger. Right, the mass of the hanger is 0.050 kilograms. Right, we can see that the hanger is the one that's, well, hanging, right? It's the one that will actually be affected by gravity in terms of its acceleration for this experiment. So we're going to calculate the force of gravity on the hanger. So we're going to do that by taking 0.050 and multiplying times 9.8. And we should get 0.49 newtons. Okay, so that's our force of gravity, so let's plug that in over here. Tension equals 0.49 newtons minus tension. To solve for t, we need to get the t's on the same side of the equation, so I'm going to add t to both sides. We'll get 2t equals 0.49 newtons. Then to solve that, I'm going to divide both sides by 2. And so then t is going to equal 0.245 newtons. Now recall that our tension is equal to our sum of forces in the x direction, and our sum of forces in the x direction is equal to our sum of forces in the y direction. So because we've solved for tension, we now know the net force in the system, because the tension is equal to the net force in the x and the net force in the y. So that's what we're going to say here. Our net force in the x direction is equal to our net force in the y direction. It's equal to our tension, which is 0.245 newtons. Okay, so now we're going to calculate the experimental net force, and for that we're just going to use F equals m times a. And so we know that because our sum of forces in the x direction is equal to m times a, our sum of forces in the y direction should be equal to m times a. Okay, so we're gonna take our mass. Now for this, we're taking the total mass of the system. So that's 0.8088, and we're going to multiply that by the acceleration in the system, which is 0.3062. We're going to multiply those two values together. So then our net force will be equal to 0.2477 newtons. Or said differently, our net force, our sum of all forces, is going to be equal to 0.2477 newtons. So we should see that the two values are pretty similar, right? Our sum of forces here is 0.245 newtons. Our sum of forces here is 0.2477 newtons. So pretty similar, only a little bit of difference. We're going to calculate how much difference there is by calculating the percent error between the theoretical and experiment values. Okay, so remember that your formula, percent error equals your theoretical value minus your experimental value divided by your theoretical value, and then times 100%. And so what we're going to do is take our theoretical value, which was 0.245, subtract our experimental value, which was 0.247 newtons, and then divide by 0.245 newtons. Now, on top, this is going to give you a negative number. These bars mean that we're taking the absolute value of whatever our number is. So, for example, if you took the absolute value of -2, that would be +2. If you took the absolute value of +2, that would also be +2. Absolute value is how far your answer is from 0. So we're going to subtract these two, and then whatever the number is, whether it's positive or negative, in this case it'll be negative, we're going to make it positive. And then we're going to divide by 0.245, then we're going to multiply by 100. When we do that, we should end up with 1.1%. So that's how much error, that's how much of a difference there was between our theoretical calculations and our experimental calculations. If you did yesterday's lab, I sort of asked you where that error comes from. It's mostly coming from the fact that we can't consider all the forces when we calculate the theoretical value. So we can't, there's no way for us to really calculate all of the drag and all of the friction and other values like that when we're calculating the theoretical value. And then also it's important to note that for our experimental value, we're measuring that based off the acceleration. The acceleration we're getting from that motion detector. That motion detector isn't all that great, right? It gets us kind of good data, but it's really tough to actually determine the exact acceleration from that motion detector. It can only do so much. Okay, and so then what you're going to do is watch the videos for these different experiments. You're going to collect data. Now again, in this experiment, we're going to be changing the mass on the hanger. So the mass on the hanger should change in each trial. The mass of the car with the weight on there is going to stay the same. You're still going to use the graph to calculate the acceleration. You're going to do that for 3 trials, and then you'll put all your data into a data table. And then what you're going to try to do is calculate the theoretical and experimental net force for each trial. So this one's for trial 1. And then after you do that, you'll find the percent error between the experimental and theoretical. And you'll do that for each trial. Let me know if you have any questions. And then, oh, I forgot, there is also a conclusion question at the end. So make sure you answer that. All right, and then that's it for today's lesson. So let me know if you have any questions or need any help.